What if your language model could analyze a very long novel, much larger than context size? The recursive language model approach makes it possible to reduce the input and extract relationships. War and Peace is over 3 megabytes, about 60,000 lines, too large for any context window. Level 3 extracts relationship sentences. Then Level 4 analyzes the filtered data and builds family trees. Its input is War and Peace. This large text will be reduced to relevant parts and analyzed recursively by a language model. The query asks to identify noble families in builder family trees. We'll enable language model delegation, the command line tools, and use DeepSeek Coder as the model. The recursive language model starts with phased processing. 5 phases reduce over 3 million characters down to about 20,000. That is an 80% reduction before the language model even starts analyzing. In the first 3 iterations, the language model uses regex patterns to find relationship terms. It searches for father, mother, son, daughter, husband, wife, brother, and sister. This identifies nearly 900 relevant lines. In iterations 4 and 5, the language model chooses Rust command line intent. It generates Rust code to extract proper names with noble titles like prince, princess, count, and countess. The code compiles and executes in milliseconds. In iteration 6, the generated code encounters a character boundary error. The language model recognizes this, switches to WebAssembly mode, and generates new code that handles special characters correctly. In iterations 7 and 8, the language model switches to language model reduce. It processes the filtered text in chunks, extracting all noble family members and their relationships from the narrative. The final output shows complete family trees. The Kuragin family with Prince Vasily and his children. The Drobetskoy family with Princess Anna and Prince Boris. And the key connections between noble houses through marriage and birth. The recursive language model also includes a web visualizer. It lets you watch the processing happen in real time. You can see each iteration, track the tools being used, and explore the results interactively. The web visualizer shows all demo levels. We scroll down to level 4, Recursive Language Model. There are 2 War and Peace options. We select the second one, War and Peace Relationships. The demo loads with a query about major noble families. The input data shows a server-side file path. The file is loaded directly on the server, no browser memory needed. Click Run to start. The visualizer connects to the backend. Iteration 1 starts, and the language model chooses Language Model Reduce. It processes the input in one chunk. The chunk takes about 20 seconds. Iteration 2 uses Language Model Query. The Rostov family appears in the output. Count Ilya Rostov and Countess Natalia Rostova are identified as spouses. Iteration 3 refines the family relationships. The language model calls continue in the background. Each step builds on the previous output, to structure the final answer. The results. Modal shows the complete Rostov family tree. 3 iterations, 4 sub-language model calls, over 3 million input characters processed in about 90 seconds. The timeline shows each step. Let us scroll through the complete result to see all of the family relationships that were extracted. The language model extracted multiple noble families from war and peace. Each family shows parents, children, and their relationships. The Rostov family, the Bolkonsky family, and connections between noble houses through marriage. Recursive Language Model is open source on GitHub. Try it on your own massive documents. The language model chooses its own tools, reducing millions of characters to just what it needs. Check out the link below. If you found this helpful, please like and subscribe, hit the bell for notifications, and leave a comment if you have questions. See you in the next one. Bye.